Hello everyone and welcome to Rudy's Retro Intel. On today's show we'll be looking at this NABU computer and the best way to keep it cool because it gets really hot. So let's see what we can do to make the machine better and keep it cool. The other is the question going around regarding the adapter for the RS422 to your PC. So the questions out there have been going around saying that you need a short cable, you can use a long cable, which is best, which works, which doesn't work. So let's answer that question today on the show and peek inside and poke around. So on the bench here we have the NABU computer opened up. Just 4 screws on the side. The whole thing just slides up and you're inside. Now this might look a little different from your NABU computer because I've done some work. So let's go into the closer view and I can show you a bit more what I've done to my NABU. So in my NABU, in order to do and create the diagnostics document, I had to remove chips and put them in sockets. As you can see, we have the video RAM, the system RAM, we have the keyboard adapter all in sockets now, and the other ones are already in sockets. And what I've done to them is I've also added heat sinks. Now the question is, why would you want to add heat sinks to it? Because without the heat sinks, the airflow doesn't flow properly. Well, sorry, let me back that up. The airflow does flow properly. It flows over the board. On this side there's vents. It flows over the board into the power supply, and then there's a fan that pulls it out to the back. Now, when you have socketed chips, the heat can get so hot in here that they actually start lifting out of their sockets. So after a couple hours, you might get an error, or my machine might be acting strange and wondering what's going on. When you open it up, you find that some of the RAM, for example, might have been loose. You reseat the RAM by pushing them back in, and everything's fine. So the best thing to do to fix and combat this problem is to put heat sinks on all the RAM, which I've done here, and all the major components, the CPU, the video, the keyboard, etc. All the major components and chips have heat sinks. Now, the question regarding heat sinks is you should put them in a certain way, and I'll show you that right here. So as we zoom in here, you can see that the heat sinks are pointing in this direction. They're all pointing in the same direction. They're going this way. Now, why is that important? Because with the airflow, you want the air to go over the heat sinks through the hole in the side here, where the vent is, into the power supply out the back. If the heat sink is put on this way, so let's say my hand is the heat sink with the fins. Now, with the fins placed this way, the air will go through, will not actually properly go through. It'll hit the edge of the heat sink and go up until it eventually goes across and through. Meanwhile, the heat is going through the fins, and it takes time for it to get to the top and go out, so the cooling isn't most efficient. If the fins are placed this way, if I can angle this properly, this way, still have the fins, but they're facing this way, the air goes through each fin individually and cools it down to the bottom, to the base of the fin. So the air is actually going to the base of each heatsink and allowing more air to get over the components, again, into the power supply, which is then vented out the back. The other addition I've added to this is what I would call a mod. It's a fan, which is a 12-volt fan. Let me just pull out a fan and actually show you what it looks like. These fans can be bought anywhere. I bought these on Amazon. There was like, I don't know, 4 in a pack, whatever. They're very small. And let's do a better shot of this. So the fan is tiny. It's a I don't know, no name brand, some Chinese 12 volt fan. Now with the 12 volt fan, these come with a connector you can just wire up, and I've wired it to the power supply adapter. In the back corner there's an adapter for plugging in power for external components like an internal floppy drive controller, the serial card, and the adapter card. Anyways, so what I've done is I've actually taken that, I bought an adapter and plugged in 2 wires. I used the 12 volts at first and found that it was very loud. So I mean, it works great, but it's a bit loud. So what I've done is I actually wired it so that it is only running off 5 volts. If I can get this connector back on, there we go. So the fan is now running on 5 volts, which makes it quieter and reliable. The nice thing is that the holes here and the holes in the case are about the same size, so you can easily take the fan and mount it inside the case. As we can see here, there we go. I just mounted it. I put a screw on this side and a screw on this side for now, just for testing to see what's best. And the location of the location of the fan is pretty much in the middle. So what I've done is I placed the fan itself approximately halfway between the two, a little further towards the front, so that most of the cooling air is happening over this section of the board. Again, all you want to do here is introduce more air in and over the motherboard and vent it out the back. Now, the extra heat that we're pushing through, the extra air, does not impact the power supply. It doesn't impact anything. It actually improves the performance of your board in the sense that it doesn't overheat. So let me plug this back, put this all back together and turn it on, and you'll see how quiet it is, and then we will move on to the next part of the video. Okay, now with the lid back on and the power plugged in, let's turn on the NABU and we'll see how loud the new fan is. So it's powering up. We have the lights coming on the front. We're going to hear a beep in a moment. Yep, it's pulling in air. We have the pause light and the power light on. And right now, I'm not sure if it's picking up in the microphone, but the fan, actually the 120 volt fan in the power supply, is actually louder than the fan that we've added to the side here. So at this point, it seems good. It's working. I've had it running for several hours like this, no problem, and I've had no issues. Before I put the heat sinks and the fan inside, I was getting chips that were being lifted from the socket, and that's from heating and cooling, and that's the expansion contraction of the ICs, which is normal in the heat. So let's put the keyboard and the adapter in, and we'll go to the next portion of the video. So here we can see my document I've created. It's the NABU computer adapter connection and build document version 1.25, created this month. You can find it on the nabunetwork.com and my Rudy's Retro Intel GitHub page. Now if you scroll to the bottom, the document's the same. I've only updated it with this portion here. Cable length. So if you're using a cable that is less than 100 feet or 30.48 meters, you should be fine. We've done a 10-foot cable, and I've done smaller ones, and others have done slightly larger, and they've been working fine. My first cable was 3 feet, 0.9 meters, and it had no problems. Now, by doing research, I found a wiki page, and I left a link in here that shows this graph. Now, this graph shows you the cable length in meters. Now, this is for the RS-422. And the data signal rate in kilobits per second. So as we can see here, I built a cable that was 10. I used 10 because it's easier to see on the graph. So it's 10 feet in length, and I'm getting 90,000 kilobits per second. You can look at this document and determine based on your length. These are in tens, so this is 10, 20, 30, 40. Now they get smaller as you go up. It's just the way the graph was displayed, but you can see you can go up to just over 1,000 feet, and you'd get about 90 kilobits per second. So depending on what your needs are, you can go with a very long cable or a very short cable. You do not need to make a small, tiny cable that's 3 inches, 4 inches long for interference and so on. And we're going to show that in a moment and prove that that's the case. Now, if you are running a cable 10 feet or 100 feet or 1,000 feet, and you are having issues, you are seeing that there are some cases where I'm getting data loss, whatever. You can use, if you're using the Cat5 cable, you can use any pair you want. There's 2 pairs in the cable that are not being used. So it's 8 wires, you're only using 4. Those 2 you can actually then twist together at the ends and use them as a ground. So you would ground it on your connector on the NABU side and on the screw down block on the RS422 side. However, I did notice that the grounding on the NABU creates interference and noise. So by leaving the ground out, everything seems to work out fine. So let's check out the video and continue with the video and see in proof, in real life, what's going on with the cable length. Okay, here we are with my adapter. I'm using the RS422 adapter, which has the USB connection into my mini computer running Windows 10. I've wired up 2 pairs of wires. I'm not sure if it's showing up properly in the camera, but I'm using brown, white brown, orange, and white orange. I've cut off the blue and the white pair and left just the green and green white pair on here. This is a Cat5e network cable, local area network or LAN cable, and it is 10 feet, actually slightly more, it's about 10 feet 4 inches. And on this end, as you can see, I've cut off the blue wire and the blue white wire and left the green to show that there's no connections. But also you can see on here that the ground connection is on the far right and there's nothing plugged in, so I'm not using ground at all. Now I'm going to plug this into NABU. We're going to fire up the software from nabu.ca and we're going to run the slideshow program. So let me put this over here, which is sitting on top of my power bar. Now people are saying, well, why do you put it on top of your power bar? Well, because there is concerns. People are saying that with the cable, and it can't be close to any power outlets or power cables because it will cause interference and so on. However, I'm saying that with a twisted pair, so the wires inside are twisted together, all the pairs are twisted together and cancel out noise. So meaning that this should work just fine. Again, it's a 10-foot cable. I have the unit on top of my power bar, which is running the Commodore monitor, the NABU computer, this monitor and this computer, all running off the same power bar, including my retro tank. So let's fire this up and see what we get. Now this site is the nabu.ca site where DJ has created this demo software, and apparently it's the best to use for this kind of work to ensure that your cable is working fine. I think there's many ways you can do it, but this is a great way. You can actually get a slideshow and you get to see that the cable is working or not without anything. So as we can see, we have different pictures loaded up. The first one was from 2000 Space Odyssey, and we'll see some more pictures being loaded up, and they're all coming from the NABU network. Here we go, the 80s, made in the 80s. So hopefully you found this interesting, and you can see that we've debunked the issue of having a short or long cable, and you'll join me for more videos in the future. Thanks and take care.